चलने वाले स्कूटर वाले आते हैं, उसमें कोट कहाँ से पहने? आर्या साहब तो बुलेट पे बैठ के आ जाते हैं, और क्या करते हैं? ये लोगों तो यहीं तक आएगा, लोगों तो दिखेगा,
बस ये कोई दिक्कत नहीं,
यहाँ तक आएगा ना। ठीक है, नहीं इसको क्या, इसको ऊपर करो।
ठीक है,
अब आ गया। टाइम बता दो, 5 मिनट है वैसे।
3 मिनट।
यस, 3 मिनट है।
फोटो की आवाज कैसे आ रही है?
वो इसमें आती है।
सब तो मैंने हटा रखा है। मैंने व्हाट्सएप पर आना भी, मैं सोचा मेरा व्हाट्सएप ऑन कर।
मनीष नहीं आएगा आज?
हाँ,
और कल भी बोल रहा था मैं तबीयत ठीक नहीं है। Good morning, learners. Welcome to the session of Management of Machines and Materials, MMPC009. Today, we will be talking about Unit 8, that is related to planning and control of projects. A project consists of interrelated activities. Network will be used as visualization of these interrelationships. A successful implementation of the project will involve planning, coordination, and control of the activities constituting the project. Each project involves consumption of certain raw materials and use of certain resources. Some of the examples of projects are erection of a manufacturing plant, preventive maintenance of a chemical plant, launching of a space vehicle, and construction of buildings, dams, bridges, etc. These projects have a very large number of activities and can be successfully completed only if the various activities are properly planned, time scheduled, are prepared, resources allocated, and a proper control is exercised during the implementation. Project management essentially deals with these aspects of the projects. Depending on the nature of the activity times, the projects will get classified into two categories. Project in which activity times can be estimated with sufficient certainty. For example, building a house. or erecting a plant. The second one is project in which there is high degree of uncertainty about the activity types. For example, launching of a space vehicle, developing a new project, etc. Time management of the project is the first case that is usually done by using critical path method. That is, in short, we call it as CP. And in the second case, using program evaluation and review techniques, that is part. Today we will be discussing about these two things in detail. CPM and PERT. Project management can be defined as a structural way of planning, scheduling, executing, monitoring, and controlling various phases of a project. To achieve the end goal of a project on time, PERT and CPM are two project management techniques that every management should implement. These techniques helps in displaying the progress and series of actions and events of a project. What is meant by PERT? PERT is program or project evaluation and review technique in an activity to understand the planning, arranging, scheduling, coordinating, and governing of a project. This program helps to understand the technique of a study taken to complete a project, identify the least and minimum time is taken to complete the whole project. PERT was developed in late 1950s with the aim to the cost and time of a project. In PERT, the project is segregated into events and activities. After discovering a proper sequence, a network is built. It is then the time for each task is calculated and a path is regulated. What is meant by CPM? CPM was developed in 1950 is an algorithm needed for planning, arranging, scheduling, coordinating, and governing of a project. It is presumed that in this method, the activity time is specified and fixed. It is used to calculate the quickest and the latest start time for each task. CPM helps to distinguish the critical and non-critical tasks, reduces the time and bypass the queue formation in the process. It is essential to identify critical activity because if an activity is hindered, it will clutter the whole process. In this process, first, list of all the activities prepared, followed by the time required by each of these activities. Then, the dependency connecting the activities decided. Here, the series of the activity in a network is defined as the path. How this part and CPM are different. We will start from the very basic things. What are the basic things that will be easier for us to understand? PERT stands for Program or Project Evaluation and Review Technique, whereas CPM is Critical Path Method. PERT is a technique used to manage the uncertain task of a project, whereas CPM is a statistical technique used to manage the activities of the project. It is, if we talk about the method, it is to control time. And on other hand, CPM is to control cost and time both. As far as progress is concerned, the part is related to research and development projects, whereas CPM is related to construction projects. If we talk about management of these, the part in part unpredictable activities are there, and in CPM predictable activities are there. It is appropriate, part is appropriate for research and development projects, whereas CPM is for non-research projects, for example, shipbuilding, civil constructions, etc. What is the advantages of PERT? Planning for large project. It is used in scheduling large projects by the project manager. Visibility of the critical path. It is used to show the critical path in a clear way. The critical path, those paths where activities cannot be paused under any conditions. Analysis of activity. This will provide the management with the progress report and completion of the project, including the budget. Coordination. This helps in improving the communication within different departments of the company. The what if analysis. This analysis benefits the company to recognize the risk linked with any project. What are, if advantages are there, so no doubt some disadvantage will be there. It is time focused method. PERT is a time bound method, so finishing project or activities on time is of high importance. If it doesn't happen, then the problem can arise. And on the other part, it is subjective analysis. Here, the project activities are recognized according to the available data. However, it is difficult in PERT projects as it is applicable for the only new project which is non-repetitive in nature. Therefore, the collection of information is to be as subjective in nature. Prediction inaccuracy. PERT does not have any past record for a framework of a project. So, prediction comes into play. The project will be ruined if the prediction is not accurate. Expensive. Too expensive in terms of time consumed, research, prediction, and resource utilized. On the other hand, what are the advantages of CPM? It provides an outline for long-term coordination and planning of a project. It recognizes critical activities, easy to plan, schedule, and control project. It improves productivity and manages the resources needed. Disadvantages of CPM. For beginners, it is difficult to understand. Software is too expensive. Sometimes to structure CPM is too time consuming. It cannot control and form the schedule of a person involved in the project. Allocation of resources cannot be monitored properly. Now, how this PERT examples look like? We will discuss everything in detail. This is how a PERT is present. The PERT diagram is present. It shows earliest start and finish time, latest start and finish time, time float, critical path, and drag amount, delay amount, or that's drag. You can see that with the red arrow, a critical path
हाँ सर। सर लाइट आ चुकी है। हाँ ठीक है सर, ओके। मैं हेलो हेलो सर।
We will continue with disadvantages of CPM. For beginners, it is difficult to understand. Software is too expensive. Sometimes to structure CPM is too time consuming. It cannot control and form the schedule of a person involved in the project. Allocation of resources cannot be monitored properly in CPM. Now, this is basically a pictorial figure which shows different components of a part diagram. It has been shown by different colors. Green is for its earlier start and finish and time flow. And the blue color is for later start and finish. And red one is critical path. That is what we call it as CPM. And these numbers, the capital letters are the activities and the numbers are basically the time. We will discuss this in detail in later on. This is representation of a CPM, that is critical path method. Red part is the basic, the sequence by which this process, this project will be completed. And it has to be shown by red arrows. Now, how to make a PERT chart? To prepare a PERT chart, following steps need to be followed. Recognize particular projects and milestones. Decide the precise sequence of the project. Create a network diagram. Determine the time needed for each project activities. Manage the critical path and update the chart as the project progresses. Now, where this is applied, that is, what is their application? These methods have been applied to a wide variety of problems in industries and have found acceptance even in government organizations. These includes construction of a dam or a canal system in a region, construction of a building or highway, maintenance or overhaul of airplanes or oil refineries, space flight, cost control of a project using CPM, using part and cost, designing a prototype of a machine, development of a supersonic planes. Basic steps in part and CPM project scheduling consist of 4 steps: planning, scheduling, allocation of resources, controlling. What is planning? The planning phase is started by splitting the total project in small projects. These smaller projects in turn are divided into activities and are analyzed by the Department of Section. The relationship of each activity with respect to other activities are defined and established, and the corresponding responsibilities and the authorities are also stated. Thus, the possibility of overlooking any task necessary for the completion of the project is reduced substantially. Second one is scheduling. The ultimate objective of the scheduling phase is to prepare a time chart showing the start and finish times for each activity as well as its relationship to the other activities of the project. Moreover, the schedule must pinpoint the critical path activities which require special attention if the project is to be completed in time. For non-critical activities, the schedule must show the amount of slack or float times which can be used advantageously when such activities are delayed or when limited resources are to be utilized effectively. Allocation of resources. Allocation of resources is performed to achieve the desired objective. A resource is a physical variable such as labor, finance, equipment, and space, which will impose a limitation on time for the project. When resources are limited and conflicting, demands are made for the same type of resources, a systematic method for allocation of resources becomes essential. Resource allocation usually incurs a compromise, and the choice of this compromise depends on the judgment of the manager. Last part, the fourth component is the controlling. The final phase in project management is controlling. Critical path method facilitate the application of the principle of management by expectation to identify areas that are critical to the completion of the project. By having progress reports from time to time and updating the network continuously, a better financial as well as technical control over the project is exercised. Arrow diagrams and time charts are used for making periodic progress reports. If required, a new course of action is determined for the remaining portion of the project. The framework for PERT and CPM. The procedure is as follows. Define the project and all its significant activities or tasks. The project made up of several tasks should have only a single start activity and a single finish activity. Develop the relationship among the activities. Decide which activity must precede and which must follow others. The third one, draw the network connecting all the activities. Each activity should have unique event number. Dummy arrows are used where required to avoid giving the same numbering to two activities. Fourth one is assign time and or cost estimates to each activity. Fifth, compute the longest time path through the network. This is called the critical path. And the sixth one is use the network to help plan, schedule, and monitor and control the project. Five useful questions to ask when preparing an activity network are: number one, is this a start activity? Is this a finish activity? Third one is what activity precedes this? Fourth one, which activity follows this? And the fifth one, which activity is concurrent with this? How this network diagram representation is drawn or done. Number one, activity. Any individual operation which utilizes resources and has an end and a beginning is called an activity. An arrow is commonly used to represent an activity. These are classified into four categories. Now I'm talking about the activities. Number one, predecessor activity. Activity that must be completed immediately prior to the start of another activity is called predecessor activities. Successor activities. Activities that cannot be started until one or more of the other activities are completed, but immediately succeed them are called successor activities. Third one is concurrent activity. Activities which can be accomplished concurrently are known as concurrent activities. may be noted that an activity can be a predecessor or a successor to an event, or it may be a concurrent with one or more other activities. Fourth one is dummy activity. An activity which does not consume any kind of resources but merely depicts the technological dependence is called a dummy activity. A dummy activity is inserted in the network to clarify the activity pattern in the following two situations. Number one, to make activities with common starting and finishing points distinguishable. And the second one is to identify and maintain the proper precedence relationship between the activities that is not connected by events. For example, consider a situation where A and B are concurrent activities. C is dependent on A and D is dependent on A and B, both. Such a situation can be handled by using a dummy activity as shown here. That means we are connecting 3 to 4 by a dummy activity which is denoted by a dotted line arrow. Number two is event. An event represents a point in time signifying the completion of some activities and the beginning of the new ones. This is usually represented by a circle in the network, which is also called a node or connector. The events are classified into three categories. First one is merge event, where more than one activity comes and joins an event. Such an event is known as merge event. Second one is burst event, when more than one activity leaves an event. Such an event is known as burst event. And third one is merge and burst event. An activity may be merge and burst event at the same time, as with respect to some activities, it can be a merge event, and with respect to some other activities, it can be a burst event. Here we can see what is meant actually by merge event, burst event, and merge and burst event. The third one is sequencing. The first prerequisite in the development of a network is to maintain the precedence relationship. In order to make a network, the following points should be taken into consideration. What job or jobs precede it? What job or jobs could run concurrently? What job or jobs that follows it? And what controls the start and finish of a job? Now, what are the rules for drawing a network diagram? Rule 1, each activity is represented by one and only one arrow in the network. No two activities can be identified by the same and event. Number 3, or rule 3, in order to ensure the correct precedence relationship in the arrow diagram, following questions must be checked whenever any activity is added to the network. What activity must be completed immediately before this activity starts? Number 2, what activities must follow this activity? And number 3 is what activities must occur simultaneously with this activity. Here we can see an example which is showing a PC card manufacturing sequence. There are different activities. We can say that there are 11 activities which are being performed. And by the red path, we can see that that is the critical path for completion of the project. Certain good habits to be practiced to draw an easy network. Try to avoid arrows which cross each other. Crossing is not permitted. Use straight arrows. Do not attempt to represent duration of activity by its arrow length. Use arrow from left to right. Avoid mixing two directions. Vertical and standing arrows may be used if necessary. Use dummy freely in rough draft, but final network should not have any redundancies. The network has only one entry point, which is known as start type event, and one emergence point, which is known as end event. What are the common errors which are being performed, which are being committed when we are drawing critical path? First one is dangling. To disconnect an activity before the completion of all activities in a network diagram is known as dangling. As shown in the figure, you can see activity 5 and 10 and 6 and 7 are not the last activities in the network. So this diagram is wrong and it indicates the error of dangling because 7 is not connected to 8 and 10 is not connected to 6. Second is looping or cycling. Looping error is also known as cycling error in a network diagram. Drawing an endless loop in a network is known as error of looping, which is shown in the figure. Unnecessary, we don't have to draw loops. It's not permitted in the network process. Redundancy. Unnecessary inserting of dummy activity in network logic is known as the error of redundancy as it is shown in the diagram. This 11 can be brought down. It's not required basically because 10 is connected to 11, 11 is connected to 12. It should be brought down. Dotted line should be avoided. Dotted line with arrow should be avoided. Now, we can have a look at this what we have studied till now. This is a basic example how this critical path normally looks like. Different activities were planned. We have a start point and we have an end point. Different activities are connected together with the help of this network diagram. The gray lines or black lines, they depict the normal activities. And the red path, these activities start 10, 40, 50, and end. This represents the critical path activities. That means the process will be followed by these activities. What is the difference between PERT and CPM? We are aware of its full form. Now, PERT is an event-oriented technique and CPM is an activity-oriented technique. Here, in PERT, it manages unpredictable activities, whereas CPM manages the predictable activities. It is focused on time control, whereas CPM is focused on cost optimization. No doubt it was, as we discussed earlier, that it came into its existence started in 1950, but later practically it was 1958 and CPM was developed in 1957. In PERT, we have three time estimates, whereas in CPM we have a single time estimate. CPM is a deterministic model, whereas PERT is a probabilistic model. Now, we take up an example how we can use CPM and PERT techniques in completing a project. This is an activity list of green construction company. They are into development of a structure or a building. So there are different activities which starts from A and ends up at N. Different activity descriptions are excavation, lay the foundation, put the rough wall, put up the roof, install the exterior plumbing, install the interior plumbing, put up the exterior siding, do the exterior painting, do the electrical work, put up the wall board, do the interior painting, install the exterior fixtures and install the interior fixtures. Now, here in the third column, we can see that it is provided to us that the immediate procedure activity is, for B it is A, for C it is B, for D it is C. Similarly, till N, all activities are provided. And the estimated duration in weeks is also provided. Now, we will be picking this and drawing up the diagram. Various questions which come into our mind after seeing this given data is how can the project be displayed graphically to better visualize the flow of the activities? What is the total time required to complete the project if no delay occurs? When do the individual activities need to start and finish at the latest to meet this project completion time? When can the individual activities start and finish at the earliest if no delay occurs? Which are the critical bottleneck activities where any delay must be avoided to prevent delaying project completion? For the other activities, how much delay can be tolerated without delaying the project completion? Given the uncertainties in accurately estimating activity duration, what is the probability of completing the project by deadline of 47 weeks? If extra money is spent to expedite the project, what is the least expensive way of attempting to meet the target completion by 40 weeks? How should ongoing costs be monitored to try to keep the project within budget? Here, the thing is that normally the project has to be completed in 47 weeks, and if we reduce the time by 40 weeks, then how much extra money will be required? This is basically what we will be trying to show you. There are three different types of information which are needed to describe a project. Activity information, breakdown the project into its individual activities at the desired level of the detail. Precedence relationship, identify the immediate predecessors for each activity. And number three is time information, estimate the duration of each activity. The project network needs to convey all this information. Two alternative types of project networks are available for doing this. First one is activity on arc, that is AOA, project network, where each activity is represented by an arc. A node is used to separate the activities, an outgoing arc from each of an immediate predecessor and incoming arc. The sequencing of the arcs thereby shows the precedence relationship between the activities. The second type of activity is activity on node, project network where each activity is represented by a node. The arcs then are used just to show the procedure activity relationship between the activities. In particular, the node of each activity with immediate predecessors has an arc coming in from each of these predecessors. Now, the information what was shown to us in the tabular form has been drafted into a network diagram. As the starting was from the initial stage, first step was excavation. And the number activities are being marked in the circles A, B, C till N. And the numbers which are being depicted over here are the time for the particular activity. As per the problem given to us, the network diagram has been drawn. Now, how to proceed further? This is the information how it is used on computer softwares. This is by using Microsoft Project using computer software. The spreadsheet used by this MS project for entering the activity list for the Green Construction Company project. On the right side is the Gantt chart showing the project schedule. This is Green's project network as constructed with MS project. You can see over here, there are a block and block consists of information. If we talk about block A, it is the exercises excavation started from 1 and completion time is 2 weeks. Sequence is being shown over there. Four informations are being provided. For normally, in all five informations are provided in a particular block. Now, different paths were studied, and we have all the paths are here. Whatever has been drawn, it has been calculated in this way: A to B, B to C, C to D, G to H, and M, and the finish one. Similarly, these six paths have been drawn. Now the question arises: as per the given problem, we have to analyze the highest time which needs to be completed, because in the problem it was set 47 weeks. Now we have to look which is that path which is using or consuming that much of time. So we can see that the fourth one, that is A, B, C, E, F, J, L, and N, and the finish, that is consuming 44 weeks. That means the estimated project duration equals to the length of longest path through the project network. This longest path is called the critical path. If more than one path tie for the longest, then they all are critical paths. So that means from the calculation we found that this project can be completed in 44 weeks. Now, scheduling individual activities. The starting and finishing time of each activity, if no delay occurs anywhere in the project, are called the earliest start time and the earliest finish time of the activity. These times are represented by the symbols ES for earliest start, EF for the earliest finish, where earliest finish is the earliest start plus the duration of the activity. Suppose the starting time of the project is 0. Since activity A starts green project, we have activities earliest start 0 and earliest finish will be EF will be equal to 0 plus 2 weeks, because 2 weeks was the time duration for activity A. Activity B will start as soon as activity A finishes. So activity B will, its earliest start time will be 2 plus, that is the earliest start for activity A, and earliest finish will be 2 plus the duration of the process, that is 4 weeks. The total comes out to be 6. If an activity has only a single immediate producer, then earliest start for the activity will be equal to earliest finish of the immediate procedure. Activity G is earliest start is earliest finish for activity D, which is 22, and the earliest finish will be 22 plus 7 weeks. That comes out to be 29 weeks. Here, the diagram has been drawn. So we can see earliest start and earliest finish of each activity. Now consider activity H, which has two immediate procedures, activity G and E. Activity H has to wait to start until both activities G and E are finished, which gives the following calculation. Immediate procedure of activity H, that is activity G, has earliest finish of 29 weeks and activity F has earliest finish of 20 weeks. The larger is 29. That means we will be using larger time. Earliest start of activity H will be equal to 29 weeks. The earliest start time of an activity is equal to the largest of the earliest finish time of its immediate procedure. In symbols, ES is the equal to largest EF of immediate procedures. This has to be kept in mind when we are having two different paths. Here, now in this diagram, everything has been completed as per the calculations. We can see that immediate procedure of the finish node, activity M, has EF 40 and activity N has immediate finish of 44 weeks. The larger is 44. Therefore, earlier start of the finish node will be equal to larger earliest finish, which is 44 weeks. That means earliest finish of the finish node, last one, will be 44 plus 0, which will be 44. That means finish time is 44 weeks if everything stays on schedule according to the start and finish times for each activity. That means if we talk about the original problem what was given to us, that means this is the basic calculations for the time where there is no delay, nothing is going, everything is as planned. Now we move to capacity planning. The operational strategy of an organization is revealed to a large extent by its investment made in creation of capacity. Creation of capacity almost always require investment. In manufacturing organizations, this is easy to see as the investments required are large. However, even in service organizations, capacity criteria requires more space, furnitures, and other accessories, including equipments. Capacity is the limiting capability of a productive unit to produce within a stated time period, and this limiting capability depends on the intensiveness of use of the productive unit. For example, by working for 7 days a week instead of 6 or 5, 6 hours restoring to overtime work, or working for 2 shifts a day, or even 3 in place of one, the capacity of a productive unit can be increased. When the transformation process in turn consists of many sub-processes, the capacity of the system is governed by the capacity of the weakest link of the sub-process having the minimum capacity. By strengthening the weakest link by balancing equipments or by subcontracting of some items, the capacity of the entire productive unit can be enhanced. Thus, there can be an increased capacity, denoting the capacity that has been licensed or permitted by the concerned governmental authorities. The installed capacity indicates the capacity that has been provided while the plant was installed. And finally, the rated capacity is used on the highest production rate established by the actual trials. Rough cut capacity planning is a process of checking the feasibility of master schedule with respect to the available capacity. How to measure how capacity can be measured. The capacity of some of the manufacturing units and services organizations are shown. That is basically a question. How capacity is measured. If we talk about capacity of a textile mill, it is meters of cloth length per day. If we talk about plywood factory, it is square meter of areas of plywood of fixed thickness per day. Capacity of mineral water or sold drinks, it is liters of liquids per day. If we talk about capacity of a hospital, that is number of bed days per month. That means we can see that capacity measurement has different units. Now, what is the process of capacity planning? Capacity planning is a process that helps to identify the capacity of production unit that is required for meeting the current and future customer demands. The design capacity of a system is the rate of output of goods and services under full-scale operating conditions. The operational strategy of an organization is revealed to a large extent by its investment made in creation of capacity. In manufacturing organization, the creation of capacity requires a huge investment, and even in service organizations, it requires a good investment for more space, furniture, and other accessories, including equipment. The strategic issues regarding the capacity planning are our expectations regarding the growth of industry and our market share, accurate prediction of market trends. Should we operate from a new large location, each within large capacity, or should we operate from many locations, each with small capacity? How much of our requirements can be met by the use of overtime, additional shift, or holiday work, or by use of subcontracting, etc. The process of capacity planning involves following 8 steps. Number one, assess company's situation and environment to predict future demands, including the possible impact of technology, completion, competition, and other events. Determine the available capacity. Translate predictions into physical capacity requirements. Develop alternate capacity plans for matching required and available capacity. Analyze the economic effect of alternate capacity plans. Analyze the risk and other strategic consequences of alternate plans. Recommend a course of action and implement the course of action if it is recommended. Now, predicting future capacity requirements. Mature outputs with stable demand growth. Outputs which are in the maturity phase of their product life cycles exhibit less volatility in their demands. In the event of the life cycle being long, the demand growth is steady and the demand can be predicted with great accuracy and confidence. Such outputs being steel, cement, sugar, salt, municipal services, and hospital services are the examples of it. Long-term and medium-term forecasts of the demand of an output are made by using the following casual forecasting methods. Regression analysis. It is a method to develop a forecasting function called a regression equation in which the demand for the output is expressed in terms of other variables which cause or control the demand. For example, demand of tires, tubes, and batteries may be expressed as a function of number of automobiles vehicles sold. Demand for furniture may be expressed as a function of new construction activities, new marriages performed during the year, and disposable personal income during the year, etc. It requires considerable time and cost as various hypotheses regarding the effect of variables may have to be tested and to develop the regression equations. Econometric forecasting method. These being an extension of regression analysis includes a system of simultaneous regression equations. For example, the demand of a product can be expressed as a function of gross national product, that is GNP, price and X. The price in turn is a function of its cost, selling and distribution, expenses and profit. The cost may be a function of production and inventory levels, and finally, the selling costs. Instead of one relationship, there are four now which are to be estimated simultaneously. And this method requires high amount of time and cost. The third method is Delphi method. It is a forecasting technique, qualitative method applied to the subjective nature of the demand values. The aim of the Delphi method is to construct consensus forecast from a group of experts in a structured, iterative manner. A facilitator is appointed in order to implement and manage the process. The Delphi method generally involves the following stages. A panel of experts is assembled, forecast tasks or challenges are set and distributed to the experts. Experts return initial forecast and justifications. These are compiled and summarized in order to provide feedback. Feedback is provided to the experts who now review their forecast in the light of the feedback. This step may be iterated until a satisfactory level of consensus is reached. Final forecasts are constructed by aggregating the experts' forecast. This is the Delphi method. Experts and anonymity. The first challenge of the facilitator is to identify a group of experts who can contribute to their forecasting task. The usual suggestion is somewhere between 5 to 20 experts with diverse expertise. Experts submit forecasts and also provide detailed qualitative justification for this. A key feature of Delphi method is that the participating experts remain anonymous at all times. We don't know why. They are just providing us their feedback. This means that the experts cannot be influenced by political and social pressures in their forecasts. Furthermore, all experts are given an equal say and all are held accountable for their forecasts. A byproduct of anonymity is that the experts do not need to meet as a group in a physical location. It makes the process cost effective by eliminating the expenses and inconvenience of traveling, and it makes it flexible. As the experts only have to meet a common deadline for submitting forecast rather than having to set a common meeting time. All these things have been constrained. Now, what is the limitation of this Delphi method? Applying the Delphi method can be time consuming. In a group meeting, final forecasts are possibly reached in hours or even minutes, sometimes which is almost impossible to do in a Delphi setting. If it is taking a long time to reach a consensus in Delphi setting, the panel may lose interest and cohesiveness. Other method is market survey. Market surveys and other studies on consumer behavior provide us a lot of primary data on the factors such as what makes the customer buy the product, what features have a high priority in customers' preference structure, what are the perceptions of the competing products, the likely impact of price changes, what are the changes to be incorporated in the product, etc. Now we move on to second phase, that is generation of capacity plans. Once the capacity requirements have been worked out, alternate capacity plans listing the size and timing of the capacity additions can be generated. If the capacity available does not match the capacity required in any year, the capacity plan also mentions whether alternate sources of capacity will be used or whether the plan is prepared with the possibility of lost sales. Now, what is the size of capacity increments? When there is a growth in predicted demand of a product, the important question is how much of the capacity has to be added and when. The two strategies for capacity addition could be easily formulated. Number one, add capacity in small increments but more and often. And the second one is add large capacity increments but less often. The two other related options are add capacity before the requirement exceeds the capacity available and add capacity after the requirement has overtaken the available capacity. That means one and the same thing. Alternate sources of capacity. The capacity of any facility also depends on the intensiveness of use. Therefore, a manager has access to a high capacity without really building additional capacity by increasing the intensiveness of use. This includes alternatives like overtime, holiday work, and additional shift working, etc. For specialized and sophisticated processing, subcontracting may not be feasible, and similarly, for process industries working round the clock, it may be possible to increase the intensiveness of use. By making the use of alternate sources of capacity, one can reduce the cost of carrying a high capacity along with reducing the risk of not using the capacity built. Alternate capacity plans may have capacity gaps which would be met from these alternate sources of capacity. We have cost volume relationships, economies of scale, and lost sales. Now, how the evaluation of alternate capacity plan is done. The alternate capacity plan developed will have to be analyzed to find out the one which is most desirable for our purpose. This involves a quantitative analysis to find the economic consequences of different capacity plans based on the assumptions made regarding what is going to happen in future. However, there are uncertainties regarding future as well as many strategic effects flowing from capacity plans, all of which cannot be quantified precisely. That is why there is a need for quantitative assessment of risk and other strategic consequences. Economic analysis for mature outputs with stable demand growth. For each alternate capacity plan, the general procedure requires that all the cash flows occurring in different years up to the planning horizon have to be listed. All the costs incurred are cash outflows and the revenues earned are cash inflows. When all these cash flows are discounted at the cost of capital for the enterprise, we get the net present value, what we call it as NPV, for each capacity plan. The capacity plan having the highest NPV will be the most attractive from an economic perspective. Economic analysis for outputs with highly uncertain demand growth. When the demand growth is highly uncertain, the consequent cash inflows from any capacity plan are not reliable enough to make a conclusion. In such a way, knowledge of the probability distribution of demand is quite useful. And in the absence of detailed distribution, one needs to know the optimistic, expected, and pessimistic prediction of demand. For each of these scenarios, the NPV for each alternate capacity plan can be computed. Different and appropriate capacity plans can turn out to be the most economic under each of these scenarios. Then comes your risk analysis of alternate capacity plans. All capacity plans are based on prediction of probable demand, and the future can never be predicted exactly. Thus, there is always some element of risk present in any planning process. What we have said above is the risks are higher in the case of new outputs and the case of mature outputs with stable demand. If demand cannot be predicted exactly, the actual demand will either be low or higher than the predicted demand. In the first case, we are likely to be burdened with overcapacity, and in the second event, we are likely to suffer from an undercapacity. We should analyze the likely consequences of both overcapacity and undercapacity. With this, we will be ending today's session and we will continue tomorrow with this part.